Bueno, buenos días. Muchas gracias por venir.
Good morning. Thank you for coming. My name is Gonzalo Gallotti, and I work in the Genexus team. The purpose of my talk is to talk about a new trend about how apps are being built. This is a trend basically based on other solutions of high technology, where we are going to focus on how we are using technologies that are different from our technological base, and then also the question of what they are for, you know, the question of NOSQL and serverless apps. So let's see what they are about and what we are doing about it. So I'll start by presenting you someone called Troy Hunt. This is an expert, an Australian expert in security. He's basically created a security platform allowing users to know whether their accounts have been engaged. And basically what he's done, he's accumulated about 600 accounts. And I tried this my site with this app, and I could see that they were engaged. You know, LinkedIn was also having problems with security. So Troy Hunt's platform is used now by hundreds of companies, for instance, Apple, Firefox, so that in a productive manner, you can tell users whether the power you've used has been engaged. It's been very successful. It's used 200 million times a month. We are using a platform that he created. It's highly scalable. Now, why am I bringing in Troy Hunt's case? Well, because some 15 days ago wrote an article, a very interesting article, about how he had created this platform. In fact, he had only created a platform that is able to scale up to 200 million users. And we are talking about high scalability. He didn't have to worry about anything else. And he said it's about $30 to $40 a month in terms of expenses. He used a serverless model, which is what many companies are using to develop games and mobile apps. And this is what I wanted to tell you in my talk. So what is the serverless thing? This is what Hunt used. Serverless is a new computer model in the cloud. It stands before the server. And the idea is that in each generation, the developer will no longer be responsible for the servers. And that's the idea. I think that at the stage where we are in, we are coming to that stage where we don't have to worry about servers. Now, to understand what that means at a lower level, let's say, in a traditional deploy, we are used to setting up a package and display it in a server or two to place a load balancer, and we have to see which is the seed to use and so on. In a serverless deploy, the difference is that we no longer use that package on my server, but we set up a package with certain characteristics, and then it's the platform that takes it when it uses it. If there is a user coming in, well, then it would run. Now, if there are 50,000 people coming in, there is no problem because they've got the necessary infrastructure to scale the app without further problems. This is something that we wouldn't be able to do, and they solve it automatically. So why is it that Troy Hunt used serverless for his platforms? Well, the fact is that he did it so that he could sleep well. He manages his site well, and he wanted to sleep well, knowing that the platform was going to scale automatically, that he needn't eliminate or keep servers. There is no question of having servers that fall or add infrastructure. So this model is managed automatically. The other interesting thing is the cost. In a traditional model, we have to pre-allocate resources. This is a graph of cost according to the demand. The red line is the serverless cost, which is directly proportional to demand. But in a server app, we have the cost. Now, low use or medium used apps, it's quite likely that they go for free in a serverless model because the free layers are very cheap, and you need really a strong demand to have to pay something. So a serverless model has two things. If we wanted a GeneXus app and take it to a serverless model and deploy where I don't have to worry about anything, I have to think about two things. One thing is a deployment issue. The other thing is how I have access to my data. From the standpoint of my deployment in GeneXus 16, we've got applications for small devices, for APIs, REST, data providers, and also daemons or other types of tasks. What does that mean? It means that we simply have to go from GeneXus when I've got my application. Suppose I want to deploy to small devices. I simply go to build, I deploy application, I select my app, I complete the data in the cloud. It would be Amazon WhatsApp services, and I would deploy it. What does this do? It sets up a package that will be deployed in the serverless platform of Amazon. It's Amazon Lambda, and there, when we deploy this app, then we have a special package code, and we have the URL, and it's the URL of the app with the characteristics I've mentioned. It can be scaled, and I pay for what I use, and I don't have to worry about servers. I would like to open brackets here because there is an interesting case that we are using in the app of this event. Perhaps you've got in your own pockets right now. Fabian Bonilla was the one who developed this app. At a certain point in time, he had to send notifications. In a mobile app, you need a task, you need a daemon to send push certifications, which sometimes you have to program them every 5 minutes. It's a batch process that you have to update it. And he had two alternatives: either to install that in his server. He needed his own server for a certain task. And the other possibility, and it's the one that he decided to use, was to make a deployment of this. So what he basically did was to deploy these two procedures, main procedures that we know of in GeneXus, and he programmed them in the platform. So the app of this event is sending push notifications directly from the serverless platform of Amazon without having to manage servers and everything that involves. Then there is something, with the question of deploy, we solve the question of the code and executing the code. But then there is something else which has to do with the access to the data. How do we connect to a serverless app? We could use a very simple database, traditional one, called server and so on. There won't be any problems there. But if we are in Troy Hunt's shoes, he didn't want to use a conventional database. He decided to choose DynamoDB. DynamoDB is used to store 600 million passwords that he had and that he obtained during his research and so on. Now, why did Troy Hunt and some companies use DynamoDB? Well, it's because it's an NoSQL database. I pay for what I use. It is scalable automatically from 0 to 40,000. And once again, I don't have to be in charge of managing it. That's the concept. Now, apart from this example of DynamoDB, this is one further example of what's happening in the industry. Products and applications and companies that are beginning to use other types of solutions. And now we can see that we are sort of flooded by new solutions in our industry. Perhaps you've heard of Elasticsearch, Apache Solr, Kafka, Dynamo, Blockchain, MongoDB. There are many solutions coming up that we are facing and that were made to solve some particular cases that now we have been faced with. Something that I always say, and that's important, is that these are new data sources that were created and they're not trying to replace the traditional databases. They are going to continue being the best way to store information. They are consistent. But when we are in a scenario where I don't care if I have consistent information, that's where this type of database play a role. And to give you an idea, we already have GeneXus clients that had the need to be integrated to this. For instance, one of the largest e-commerce sites using a GeneXus had to be integrated with Apache Solr to solve the question of searches. Elasticsearch is used in Mexico to monitor logs. There are clients in Mexico and in Panama using streaming mechanisms based in Kafka to decouple, to be able to be easily integrated in companies, in the company's processes. And I think this is an interesting issue. It's going to be very important in the next few months and years. So what we are seeing is that there is a need here. We've got a group of solutions, and there are clients that need to integrate them. So what we've been working on is this version 16 is to support the native integration of these new data sources. And I'd like to show you a very brief demo in GeneXus if we wanted to work with these new data sources. First of all, let me show you DynamoDB. That's a database in the cloud managed by Google. This is a dashboard. We've got two tables, one of counts, another one of passwords. Here we've got an element because it's a non-relational database. This is just JSON with a value key. I don't have to have any organization there. And here I've got an element. So how do I visualize the idea to incorporate a new database? So this is a service. This is the new way to be integrated and as a service. This is the Dynamo with the users and the password. And so what's the following step? We have a tool here allowing us to be integrated and bringing the definition of tables. I'm going to execute it. This is the Dynamo database where I can also choose other suppliers if I wanted. What GeneXus is going to do is to connect to Amazon. It's going to bring in the data in that data store. We're going to select the password transaction. We're going to import it. And there we can see that the GeneXus brought in the transaction. The data. This is a very frequent transaction as we are used to using with SQL Server or MySQL. And we can use all the patterns and functionalities and rules, everything that we are used to. So once again, everything that we are used to, patterns, rules, events, the structure, we bring it to the GeneXus world independent of the data sources. We execute it. We can have access to work with, and there we are seeing a GeneXus app connected to this data source. I could insert registers. There I go. If we go to Dynamo, we're going to have registered also inserted there. All the features are available independent of this new data source. Why was it important then? I mean, we could have integrate this in the previous versions. We could integrate with DynamoDB, but I think that the real power here is to be able to use the for each, to use N components, to use the new command. That's where the power of GeneXus is, where GeneXus has always outstood. So these data sources can be integrated in a native manner. Let me execute this Pro. It's just to load it. That's the end. Refresh. I'm going to see all the new records. Paging works out fine. Once again, refresh. And we have the data stored and functioning in a sync manner. So this is, while going back to our presentation, this is the last thing I wanted to share with you. In GeneXus 16, we are announcing the support for OData ready in the release version on Monday. And the upgrade of version 16, we're going to be including support for blockchain, and also to have access to DynamoDB as the first non-relational database fully integrated in GeneXus. Most certainly in the next few months, we'll be including other technologies or other needs that we come across, and we'll be including other technologies. So I think that's it, these two things. This is what I wanted to share with you, these two pieces of news. On the one hand, the support to be able to integrate non-relational database that will allow us to improve our integration with the ecosystems where we are in. And on the other hand, to integrate in the cloud world that is moving very quickly. And I think that the serverless thing is something that will bring about something very positive in the near future, so that we can have apps in a much easier way and with a lower stress level when they go into production. So we are going to be working on this with this in version 16. I hope you've liked it. Thank you.